Okay, the vertex formula, it's used for f of x equal to ax squared plus bx plus c, where a does not equal 0, so you need to be in standard form to use the vertex formula. And it breaks down into the x value is actually negative b over 2a, and the y component is 4ac minus b squared over 4a. This is the general formula for the vertex formula. But I'm going to make it a little easier for everyone. So in order to find the x coordinate of the vertex, we're going to use x equal to negative b over 2a. That's what we're going to use. But to find the y component, we're going to use the found answer of x that we found, and we're going to substitute back into the original equation to find the y coordinate. So remember, yes, you can use this formula here, but memorizing this formula might take some time. So it's easier just to find your x component and then substitute back into the original equation to find the y. So in example 3, it says h of x equals x squared minus 2x plus 5. They want us to first use the vertex formula to find the vertex. Part B is find the x and y-intercepts, if they have any. And C is graph the function. So we're going to start with part A using the vertex formula. So on writing down my problem, h of x equals x squared minus 2x plus 5. And remember, the x equation portion of the vertex formula is x is equal to negative b over 2a. So when we look at our equation here, the a value is a 1, the b value is a negative 2. So we have x equals negative, and in parentheses I'm going to put a negative 2 because that's what the b value is, 2 times my a value, which is a 1. So we have x equals negative and a negative makes it positive 2. 2 and 1 is 2. So 2 divided by 2 is a 1. So we have an x equal to 1 value. Then they want us to find the y portion. So I'm actually going to use substitution and plug the 1 back into our original problem. So h of x, because we want to find what the y is equivalent to, x squared minus 2x plus 5. I wrote my original problem. And I'm going to substitute in a 1 where there's an x. So we have 1 squared minus 2 times 1 plus 5. 1 squared results in 1. Negative 2 times 1 is a negative 2, and then the positive 5. We do our math. I had $1, I spent $2, I'm short $1. Then I found 5 more dollars, I ended up with 4. So our vertex is 1, 4. Now we need to find our x and y intercepts. So we're going to tackle part B. So for our x-intercepts, you're going to take your equation, h of x equal to x squared minus 2x plus 5. To find the x-intercepts, we're going to use factoring. So what we need to do is take our equation and set it equal to 0. So I'm going to replace this with a 0. The right side slides down. And we're going to factor. So we want numbers that multiply to 5 that can add to 2, and there are none. So we need to use the quadratic formula. So a is equal to 1, b is equal to negative 2, c is equal to 5. So x equals negative b plus and minus square root b squared minus 4ac, all divided by 2a. So we have our equation, and now we're going to use substitution method and plug in the pieces we want. So we're going to substitute in for the b, a, and c. So negative of b, which is a negative 2, plus and minus. It's negative 2 in parentheses squared, minus 4 times a, which is a positive 1, c, which is a positive 5, all over 2 times our 1. We're going to simplify inside. So we have negative and negative makes it positive 2. Negative 2 squared makes it positive 4. I'm short 4. Negative 4 times a positive 1 is negative 4. Times a 5 is still negative 20 over 2. Do the math inside. So we have 2 plus and minus, that's square root of negative 16 over 2. Remember, there's a negative in sign, so it means we have an imaginary root. So we have 2 plus and minus. I'm going to make it positive 16, and then negative 1 in the radical. So x equals 2 plus and minus, that is going to be 4i over 2. At this point, I'm going to stop with this because x-intercepts means they have to be real numbers. Since this has an imaginary answer, there is no x-intercepts. To find your y-intercept. To find the y-intercept, we're taking our equation, which was h of x equals x squared minus 2x plus 5. And we're going to replace the x's with 0. So we're going to put 0 squared minus 2 times 0 plus 5, resulting in 0 minus 0 plus 5. I get a y value of 5. So the y-intercept, which we do have, is 0, 5. Part C of our problem wanted us to graph the function. So give me a sec to get some graph paper. Okay, so part C of example 3 says h of x is equal to x squared minus 2x plus 5. I pulled our information we found, which was our vertex, which was 1, 4. We did have a y-intercept, which is at 0, 5. And because we know our vertex is at 1, 4, we know that we have an axis of symmetry at an x equal to 1 value. Remember, there are no x-intercepts, which means it does not cross the x-axis. We start out with our vertex point, which is at 1, 4. We put our dot, and it hits the y-axis at 0, 5. Remember, we have an imaginary dashed line, which is our axis of symmetry, going through the vertex point. That is our dividing point. So it means we are a distance of 1 unit out from our axis or 1 unit out on the other side. And then we graph our parabola. And because we did not cross the x-axis, that's why we have no x-intercepts. This means we have an imaginary answer for our x's. Great, guys. We've reached the last example of this unit. Example 4, so it's a word problem. It says the crew from Extravaganza Entertainment launches fireworks at an angle of 60 degrees from the horizontal. The height of one particular type of display can be approximated by, and they gave us an equation, it says h of t is equal to negative 16t squared plus 128 square root of 3t, where the h of t is actually measured in feet and the t is in seconds. So part A wants us to ask us how long will it take the fireworks to reach their maximum height round to the nearest second. One thing you need to look at this problem is that the t's are indicative of where the normally variable x would be contained. So we're going to use the vertex formula. Finding x. X is equal to negative b over 2a, but in this instance we are changing it to t equals negative b over 2a because it's in representative of time. So it's with respect to time, so we're going to use a t instead. Thing we need to know is our a value. An a value for us in our equation is negative 16. And the b value is 128 square root of 3t. But we are not going to use this portion. We're just using our whole number values. So we don't need this part. We're going to plug it in. So we have negative of 128 in parentheses, negative 16 times 2. So we have a negative 128 divided by negative 32. So when you do the math, 128 divided by 32, because two negatives make a positive, becomes a time of 4 seconds. Part B of our problem says find the maximum height reached round to the nearest foot. So maximum height, we've already found our time frame it took us to hit the maximum peak. So we're going to use our 4 seconds to substitute in to find our answer. So you're going to take your original problem, h of t equaling negative 16t squared plus 128 square root of 3t on the inside. And we're going to substitute in the value of 4 for wherever there's a t. So negative 16, we're going to write 4 squared plus 128 square root of 3 times a 4. We do our math. We have equal to negative 16. Remember, exponents have to be squared first. That becomes positive 16 there. 128, that's square root of 12. When we do our math, you're going to do 16 squared. But because it's negative, it's going to become negative 256. 128, and you're going to multiply by the square root of 12. Square root of 12 happens to be 3.46. I'm using decimal answers in this one for right now so we can figure out where our solution is. Negative 256 slides down, and then you're going to do 128 times your 3.46, which is 442.68. You're going to subtract 256 from it, giving you 186.68, which means it said round to the nearest foot, so it's 187 feet.